So this is Geometry Semester 1. It's a unit called Similarity, which is unit number 8. And it's the third lesson within that called Side, 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 or SSS Similarity Postulate Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So some students absolutely have trouble finding those notes. Let's show you where those are. All right, so here's the website name, creatormath.weebly.com. If you type that in, you should get to this home page. All right, if you have any questions about the composition book, you guys, scroll down under that home page till you see the words composition book and the picture of the composition book. Please watch all these videos, follow all these deadlines, and follow all these instructions. If you do, you should have a 90 to 100% on your composition book. All right, this is a problem set we're going to do on this video. So now we're going to go to Geometry. That's the tab. Under the tab, you'll find all of the video lessons. You'll find the vocabulary. Here's a PDF right here of all of the vocabulary for the entire school year, and it is searchable. Download it to your device, and then Google, how do I search a PDF on the device that you're using. It's slightly different for each device. Also, the problem sets and the notes are here. So I'm going to scroll down to the proper semester. Please pay attention to that first. So I need semester 1. This is the table of contents for the whole semester. This video is on semester 1, and these table of contents should have been written by you on your composition book on pages 2 through 6. It's about 3.5 pages long, but it maps out every page that needs to be filled in on the comp book for you to get that 90 to 100%. And there's videos on the home page back where we were on how to number the pages of the comp book and how to fill out all the different verse pages, all right, and examples of great comp books. So let's scroll down to the right unit. This happens to be unit number 8. So right here, we're way down here, similarity. Notice there's 1, 2, 3, 4, 5 lessons in this unit. This is lesson number 3. So we're right here, SSS, Side, Side, Side Similarity Postulate. Here are the pages where these notes go in your comp book. Please don't take this video's word for it, but go find the original table of contents at the time you're looking at this video. These pages probably might have changed, all right? So here are the notes, the problem sets we're doing now, and the video solution will be linked here. We're going to click Notes. Fair warning, sometimes it takes me a couple times to load this. You'll either see how it cleared up there. That's what loading is for my device, all right? And it takes a second. This is a picture of my notes. Sometimes it will be a picture of the notes on the board, a little bit different, but you can expand it and you can copy these onto, it's got the relevant standard, it's got an essential question, and then it's got side, 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 similarity postulate, and examples here. Are these triangles similar? So keep in mind, let's go back through geometry. Geometry has 2 issues, congruence and similarity. Similarity is the idea of proportionality, and I always pull out some model, right? A scale model is proportional to the original helicopter. This is a Dolphin, aerospatial Dolphin in Coast Guard colors, and this one is 1/48th scale. So if you took every dimension of the original real helicopter and divided each piece by 48 and put it all together, you'd have this scale model. And the cool thing about a scale model is it's the same shape as the original, but it's a different size related by a scale factor. Right? And we understand this intuitively. We understand this. But in geometry, we mix it up on you, and we call this similarity. It's a little bit of a strange name, given the fact that the word similar means kind of alike in general conversation. But in geometry, it has a very specific meaning. It means proportional. The exact same shape, but different size, related by a scale factor. So we have different postulates, which is a rule or definition that allows us to understand whether these 2 triangles are proportional or not. And one is we check the scale factor of each side. So we map out the sides. Here's a 5, 7, and 9. It goes low, medium, and high, right? So we go over and look at the other triangle. Low, medium, high, right? 15, 21, 27. And we go in that order. So the 5 over 15, that's 1/3. Then we take the 7 over 21, that's 1/3. And we take the 9 over 27, and that's 1/3. The scale factor is it's going from smaller to bigger. right? So in this case, it would be 3 times. We're multiplying 3 to go in this direction from small to large. The scale factor would be 3. If we go back from the large to the small, the scale factor would be 1/3, right? So scale factor is 3 or 1/3, depending in which direction you go. And we understand that. If you take the smaller model and you go up to the larger, you would multiply every size by 48 to get up to the larger. If you have the larger and you want to get to the smaller, you would divide each piece by 48 to get down to the smaller, right? We understand that intuitive understanding of going from small to big or big to small. So you're going to copy all these examples into your comp book. Here's another one talking about the scale factor in one direction is 4 and the other direction is 1/4. Here it is again, a third one. So we cannot say that these are similar. Notice this is an example where here's low, medium, and high, 5, 6, 8, right? Here's 25, 30, 48. So the 5 to 25, and that goes 1/5, right? Then we go 6 to 30, that's 1/5. But now we take the 8 and divide it by this one, 48, and we don't get 1/6 anymore, right? Or we get 1/6 now. We don't get 1/5 anymore, excuse me. Because 6 times 8 is 48. Now all of a sudden this has changed for that third side. So all 3 sides must be proportional by the same scale factor to say that these are proportional. So this one is a case of an example of one that is not proportional because the scale factor changes. Vocabulary is similar means proportional. Scale factor is the value by which 2 shapes are related. Proportional means that 2 shapes are exactly the same but different sizes related by a scale factor. And corresponding is same location parts but on different shapes, right? Corresponding. Again, this is the third lesson in this, so some of these you've seen before in prior lessons. And let's see what the problems are and see if we can solve some of these. What does congruent mean? So in geometry, congruent means exactly the same, all right? It means that corresponding angles and corresponding sides are exactly the same, right? And if we ask why do we use congruent in geometry rather than just saying equal, I say it's because there are multiple aspects of equality. So back in the old days, you had 3 equals 3. Now you have, is this shape exactly the same as this shape? Well, there's angles to consider, right? And there's side lengths to consider. There's multiple aspects of equality we have to consider. So we use a different word here. We use congruent. Corresponding are the matching sides. This one corresponds to this one. This angle corresponds to this one. Same location but on different shape. That's what corresponding is. Now let's look at the word proportional. What does proportional mean? So this is the word similar in geometry. And it means exactly the same shape but either smaller or bigger related by a consistent scale factor. Right? That's what proportional means, and we use a proportion to solve it. See other lessons for examples on that. What's the symbol for congruence? It's an equal sign with a squiggly over it. It's this one here. What's the symbol for similarity? It's this squiggly sign. Look at your keyboard in the top left corner if you want to see a similarity symbol. Okay, right here. Right? Are the following shapes similar? Are they proportional? So, first things first, we have to match up these two. Let's rotate this around this way. Notice how this has got the hypotenuse on the bottom, and here the hypotenuse is on the top. If we rotate it so the hypotenuse is on the bottom, that would rotate this side here, which is 15, and this would come like this. The 36 is down here on the hypotenuse, the longest side and across from the largest angle. We can just physically see it's the longest side, right? D rotates to here, E rotates to here, F rotates to here. So now we're matching up 5 to 15, right? 5 over 15 is 1/3. And we're matching up the 12 to the 36. 12 over 36, 1/3. Check, check. So the scale factor is the same, or threefold, right? 3 times 5 to get 15, 3 times 12 to get 36. So in this case, we're going smaller to larger. The scale factor is 3. So, and then we have the included angle here. And D would be right here, has 1 tick mark, 1 tick mark. These angles are exactly the same. So this is the side angle side similarity postulate. Okay, side angle side similarity postulate. And we write it this way. Triangle ABC, this one, is similar, that's a similarity symbol, to triangle DEF. All right, and why can we say that? Because it's an SAS, a side angle side similarity postulate. We know if that's true, then those two triangles are proportional. All right? Given the following two shapes are similar, now they're telling us it's similar, what's the scale factor? So this is the same one we just did. Notice it's going 5 to 15 and 12 to 36. To go from here to here, we had to multiply by 3. The scale factor's 3. We already solved it on the last problem. Go back and look at it if you need to see it. And then, given that the following two shapes are similar, these are similar, what is the scale factor? Now look. So let's just review really quickly. Here we went ABC, this one, to DEF, this one. Now they're asking us DEF to ABC. Now we're going this way. So we're going from larger to smaller. We would have to divide everything by 3 to get back. So the scale factor in that direction is 1/3. And in one direction it's 3, right here, and in the other direction it's 1/3. Right? So if you're shrinking, you got to divide by a number. If you're expanding, you got to multiply by a number. This may be the easiest way to understand that. Are the following shapes similar? If so, why? Drawings may not be to scale, so they may be drawn weirdly, but we're going to look at the facts. First, let's rotate this around like we did the other. Let's put the hypotenuse on the bottom. That would make the D coming to here, the E coming to here, the F coming around to here. That would make this side 40. If we rotate around, this side is 50. And the included angle between the 50 and the 40 is a double. And notice it's double here also. So the 10 corresponds to the 50. We had to multiply by 5, right? 5x. The 8 corresponds to the 40. We had to multiply by 5. So we're going 5-fold in this direction. And it is a included same angle with 2 tick marks. So we have side, angle, side. So yes, these are proportional or similar triangles because of the side, angle, side similarity postulate. We say triangle ABC is similar to triangle DEF. Now I think they're going to ask us the scale factor. In this direction we went 5, and the scale factor in the other direction we went 1/5. Right? So let's see if they go ahead and ask us that. So given that they are similar, going from ABC to DEF, so going in this direction, it's the same ones, 10 to 50 and 8 to 40, it's 5-fold. That's what we just said. And in the other direction, in reverse, now going from DEF to ABC back in this direction, it's 1/5. So they kind of took one problem and made it into 3 problems. So it seems like it's a longer problem set, but it's a little bit of advantage when we solve it once. All right, let's get to the next one. So again, let's rotate this around so we can get it in the same orientation as the given. Let's trace around where this would be. The E would be up here, the D would be here, the F would be here, right? D to E is 20, E to F is 40, and D to F is 48. D to F is 48. So let's match corresponding sides. The 5 corresponds with the 20. And what did we do? We multiplied 4x, right? We multiplied by 4 times 5 is 20. The 10 went to 40, and the 12 went to 48, all being multiplied by 4. So yes, they are similar. They are proportional by the side similarity postulate, because we don't have any angles involved here. All we have are 3 proportional sides. We know that these are now similar because of the SSS side similarity postulate. If I'm right about the next question, it's going to say what is the scale factor going from triangle ABC to DEF? It's 4. And the next one's going to say what's the scale factor going from DEF to ABC, and it's going to be 1/4. So let's see if I'm guessing right. Okay, so yes, they are. This is the same one. Now they're asking what's the scale factor going from this way? 4. Said 4-fold, right? And just, look at it. 4 times 5 was 20, and 4 times 10 was 40, and 4 times 12 was 48. Then, given the following, what is it in the reverse order, DEF to ABC this way? Well, if it was 4 going one way, it's 1/4 going in the other. You had to multiply it by 4 to get bigger. You had to divide it by 4 to go back to the original. All right, here's another one. So this looks like the same thing. I'm going to try to match these up. I'm going to go small 5, okay, to small 30. So I'm not even going to rotate it. I'm going to wing this one a little bit more. We're just going to eyeball it, all right? We're going to match up 5 to 30, excuse me. Didn't we have to multiply this by 6? 6 times 5 is 30. The next highest is 8, and the next highest is 48. So these are corresponding. So 6 times 8 is 48, check. And then 10 matches up with the largest one, the largest with the largest. 6 times 10 is 60. So this is consistent side, side, side. These are proportional. They are proportional by the SSS Similarity Postulate. We can now say triangle ABC is similar to triangle DEF. Now they're probably going to ask us the scale factor in this direction is 6, in that direction is 1/6. I like it that the problem sets are predictable. Makes it easier for me to get it down. And I understand what they're doing now, right? In this direction, we went 6-fold. In this direction, we have to go backwards. You're going to go 1/6. So now we're going DEF, this direction, 1/6. All right, so these are similar triangles. Make sure to match up the title of this video with the problem set you're doing. That's the way it works. This is Geometry, Semester 1. It is the 8th unit called Similarity. It is the 3rd lesson called Side, Side, Side Similarity Postulate Practice. It's on creatormath.com under the Geometry tab. Hope this helps.